Hello and good morning, CTS266 Section 840 students for the Spring 2016 semester at Anne Arundel Community College. This is the CCNP Switch course, and this morning's video tutorial is going to be a video tutorial from our Cisco networking, or I should say our Cisco Learning Labs curriculum. We're going to be taking a look at Discovery 5, where we're going to be looking at DHCPv6, or in other words, how do we get an IPv6 address automatically? So we're going to be taking a look at 3 different and distinct ways that we can set up IPv6 to auto-magically give addresses out. We're going to talk about SLAAC, Stateless Address Autoconfig. We're going to talk about Stateless DHCPv6, and we're going to talk about Stateful DHCPv6. So let's go ahead and jump in here. We're going to be spending most of our time on DSW1. Let's go from user exec to privilege exec, and then into global config. So if I were to say do show IPv6 interface brief, let's see what we have configured so far. And you can see we've only got VLAN 30 configured. So let's create our interface VLAN 10, and we're going to say IPv6 address, and we're going to give this an address of 2001:db8:A::1/64. Now, if I run this command again, that do show IPv6 interface brief, and we come down to the bottom, you'll see that what happened here is we ended up with not only a global unicast address, but we also ended up with, and here is the global unicast address, but we also ended up with an auto-magically generated link local address. And so how did we end up with this link local address? Because we did not configure that. So remember, with IPv6, every interface must have a link local IPv6 address. So if we're doing IPv6 on that interface, it's going to have this FE80 link local address assigned. Now, we can either assign it manually, or we can allow IPv6 to sort of auto-magically make this happen for us using the EUI64 process. And you can see right here, we see that FFFE sort of in the middle of the address, and that is a clear indicator that this address was assigned or arrived at via the EUI64 process. And so let's do a quick review on that. How is that being generated? Well, it's all based on the MAC address of the interface. So VLAN 10 is my interface. So if I say do show IPv6 interface VLAN 10, and actually let's say do show interface VLAN 10, sorry about that. And you can see that there is the burned in MAC address, right? The BIA burned in MAC address. So if we were to say, let's run these commands again here. So let's say do show IPv6 interface brief, and if we came down here and then I rerun that show int VLAN 10, you can see here is the burned in MAC address, and here's that link local address we ended up with. Now remember, IPv6 addresses are 128 bits. So when I say EUI64, what we're doing is we're coming up with the last 64 bits. Let me try to make that a little longer there. We're coming up with the last 64 bits of what is ultimately going to be our IPv6 address that's going to be 128 bits long. So if that's my burned in MAC address, how do we arrive at this? Well, it starts out, and I'll write it up here. So remember, link local addresses are going to start with FE80:::. So we have 64 bits here that are represented here. So that's 64 bits. So if I were to write all the zeros out, it would be FE80::, and then 3 hextets of all zeros. Now we need to get the last 64 bits of the address. And so how do we convert the MAC into what we see here? Well, it's very simple. We're interested in the 7th bit. So A in decimal is 1010. I'm sorry, in binary is 1010. Then we have another A, 1010. Well, if we look at the bits and count from left to right, we get 1, 2, 3, 4, 5, 6, oops, sorry, 7. And so this bit right here is the one that we're interested in. So what we do with this bit is we flip it. And if it's a 0, we make it a 1. If it's a 1, we make it a 0. And so if I were to change that to a 0 and we were to rewrite this, it would be A8 Baker Baker period CC80 period 0100. Now remember I said the FFFE, that gets put in the middle of the MAC address. So literally the middle is right between the C's, or the C, and the 8. So I would rewrite this up here as A8 Baker Baker colon Charlie Charlie, and here's my FFFE. FE, whoops, 80 colon 100. And there is my link local EUI64 generated IPv6 address. And so even if you don't manually assign that address to the interface, Cisco iOS is going to create it automagically for you. And again, the process is simply flipping the 7th bit, sticking FFFE in the middle, and then appending that to the first 64 bits, which is going to be this FE80 colon colon, keeping in mind that in here between these colons we would have 48 bits. In other words, we'd have 12 zeros. Right? There'd be 12 zeros. So let's clear that off, and we just use the rule of zeros to condense it down to FE80 colon colon. All right. So we have the address configured on DSW1 for VLAN 10. And now let's go ahead. We're going to work on PC1 here. So PC1 is going to get its address via stateless address auto configuration. And not sure what's up with PC1 here, as I'm typing in one character, it's giving me 2. So hold on, let's see with PC1 if we can get this to real quickly here reload. So PC1 power cycle, let me power cycle it and see if that helps. I've had this happen before, and unfortunately, okay, so there we go. So it power cycled, so, and now it's giving me 3 E's. All right, so that is not good. So let's see here. We've tried to power cycle it. Let me come over here and let's clear the console. Maybe that'll help. So we'll do a clear console on PC1. Clear disconnecting. Now it's still giving me the 3 E's. Let's make sure this is not a problem. So it's not a problem on PC2, and it's not a problem on PC3. It seems to be PC1 is just simply hung up. Let's do this. Let's manage devices one more time, and let's try to reload the config on PC1 and see what happens. So we'll give it a second here. PC1 comes up, and it's even worse than it was before. Now it's giving us 4 E's. So PC1 is pretty much on the fritz here. Well, we'll talk. Oh, let's just go ahead and talk it through. So what I would do is I would go to interface Ethernet 00, and let's go ahead and write these commands out. So I would jump onto the PC in question, right? And it's actually a router, but we're calling it a PC. I would jump on Ethernet 00 and I would type in IPv6 address autoconfig. Whoops. I would say IPv6 address autoconfig. And then I would simply say no shut. And this IPv6 address autoconfig command is going to get me via stateless address auto configuration, right, or the SLAAC process. It's going to get me an IPv6 address, and it would pull it from the what am I trying to say? The global prefix range, right, that we had identified earlier, that 2001 DB8:A. And so this is how SLAAC will work. And again, It's very straightforward. We configure an IPv6 address here on the VLAN interface, and then we come down and we just simply say IPv6 address autoconfig no shut. All right, so let's go ahead. We're going to move on since PC1 is obviously having some issues here. And now let's talk about, excuse me, let's talk about stateful. So we talked about SLAAC, stateless address autoconfig, and that's only if you want to get an address. Well, what if I want to do something sort of along the lines of what we did earlier, where we did an assignment of the addresses from a quote-unquote DHCP server. So let's go ahead and take a look at what that's going to look like. We're going to assign an address prefix range now. So on DSW1, I'm simply going to say IPv6 DHCP pool, and we're just going to say V6 VLAN, and this is going to be in VLAN 20, I believe. Yeah, V6 VLAN 20. We're going to be working with PC2. So if I do a question mark here, you can see we've got kind of a scaled down version of the commands that we had seen with IPv4. So, and again, when you're doing DHCPv6, the reason to do it is because you have additional information you want to pass down, like a domain name, Cisco.com. Maybe it's a DNS server that you want to pass down. So you can say 2001:DB8:Charlie1::53. Maybe you want to give an SNTP server, and we can just simply say, I believe, yeah, same thing, address is what you have to put in there. Then you put the address in. So 2001:DB8:99::123, right? The port number for SNTP or for NTP. So we'll put that in there. Now, here is the other significant difference. Remember, with stateless address autoconfig, we didn't create, like with IPv4, it's the network statement where I specify the network from which we're going to be assigned addresses. With IP or DHCPv6, you give it an address prefix, right? So I'm going to simply say address prefix 2001:DB8:14::/64. So that's what we're going to use for our address prefix range. So it's from this range that a randomly generated IPv6 address is going to be passed down to the client. Now, the other thing to remember here, right? Remember I talked about in DHCPv4 how we had excluded addresses. Well, the excluded address or excluded addresses command, it does not exist with IPv6 because the odds of getting a duplicate address are infinitesimally small, right? It's virtually impossible to end up with that same address being assigned. So what does VLAN 20 look like? So do show run int VLAN 20. What do we see right now? We don't see anything because I have not created the VLAN 20. So let's get in there. Interface VLAN 20. Thought we'd already gone in there. All right, so here's where we're going to assign our IPv6 address to VLAN 20. It's going to be 2001:DB8:14::1/64. And remember that this is the address, the prefix range from which we're going to be assigning those addresses. And then we're also going to say IPv6 DHCP server, because again, with DHCPv6, it's not good enough just to identify the pool, right? We have to actually go onto the interface where we want that DHCPv6 server to be running. And so we would say v6 VLAN 20, give the name of the pool. So that means that everybody in VLAN 20 has a possibility here, if they come up with the right configuration, to receive a randomly generated, now remember, we're talking about stateful DHCPv6 here, not SLAAC, which is the first way to get the address, and not stateless DHCPv6, which is the second way to get an address. Stateful DHCPv6 is the final way to get an address. And again, in the discovery activity, it doesn't go into great detail, so I would definitely like to recommend to you a video that I did here back in October of last year, but again, still 100% relevant to our conversation, where it talks about, we're getting ready to talk about the other config flag. And you've got the manage config flag, or the M bit, the O bit, and the autonomous config flag, or the A bit, right? So when you take a look, there's these 3 bits, and all 3 of those bits can either be on or off, right? 0 being off, 1 being on. And so I actually, in this video, walk you through every single possible combination of these 8 bits and show you how the addresses are being assigned, right? As the difference between between SLAAC, between stateless DHCPv6 and stateful DHCPv6, and we configure every single combination of these 8 combinations that you see here to show you how this is going to work. And so again, this goes much deeper dive, talk about the privacy extensions. I have a MacBook that gets configured. We pause for 24 hours to see what happens with the temporary IPv6 addresses. And again, it's a very good video in terms of walking through all the different possible combinations of the M bit, O bit, and A bit, and how that affects your DHCPv6, your DHCPv6 configuration. All right, so here we are in VLAN 20. We've just configured the IP for VLAN 20, 2001 DB814::1. We've identified that the DHCP, the DHCPv6 server that's going to be running here is this v6 VLAN 20 DHCP pool we created earlier. And now we're simply going to say no shut. Okay. We already mentioned that there is no excluded addresses command with DHCP v6, because again, the odds of you getting a randomly generated IPv6 address that's identical to another one that has already been generated is virtually impossible. All right, so now here is what we're going to do. So we've configured VLAN 20. Let's get on to PC2. And let's hope that it's going to cooperate, and it still does. So let's go into Global Config, Interface Ethernet 00. So this is the interface that PC2 has into VLAN 20. So we're going to say IPv6 address DHCP, telling it that we want it to use DHCP to get its address. And I'm going to say IPv6 enable in order to give us a do show IPv6 interface brief. As soon as I said IPv6 enable, I immediately receive or configure my own link local via the EUI64 process, my own link local IPv6 address. And that's what that IPv6 enable did for us. Now we're going to say no shut. Because again, we don't have a global IPv6 unicast address, but that is about to change. So if I were to say do show IPv6 interface brief now, you can clearly see that we end up with, and it's definitely not EUI64, because where is the FFFE? The FFFE. We don't see that here. We see it in the link local address right there, right? So that's where we see it in the link local address. But we're getting or receiving this address being randomly generated based off that address prefix we configured earlier, 2001 DB8::14. Everything we get after that is randomly generated, right? So if I were to go to, let's see, let's clear this here. So if I were to say do show IPv6 DHCP, do show IPv6 DHCP interface Ethernet 00, you can see that we've been given the address, and there is the address that we're looking at. We've got the preferred lifetime and the valid lifetime in the same meanings as we had looked at before. It also shows us that additional information, right? So here's the additional information that SLAAC is not going to be able to provide to me. I've got my DNS server information. I've got my domain name information. I've got my SNTP DNS server information. So that's why you would want to use one of the either stateful or stateless DHCP configurations. So now we're going to take a look here at PC3. And it's interesting here, they have us jump from step 7, looking at PC2 to PC3. And it's talking about, yeah, so this is going to be our stateless DHCPv6. And so let's go ahead and jump in. Let's take a look at that here. So if I were to come up to PC3 and I were to say show IPv6 interface, interface Ethernet 00, what we're going to see is we have a link local address. Clearly it's EUI64. There's my FF:FE in the middle. So without a doubt, this has been EUI64 generated on PC3, and it says it was it's been pre-configured here. And so what we're going to do, and let's take a look at that. Let's say do show run. Let me see. It says it's a do, or actually just show run. It says it was pre-configured. So show run interface Ethernet 00. And there's our IPv6 address autoconfig. We've got no IP address, no IP route cache. Okay, so this has been pre-configured. We didn't make this change. So they've actually pre-configured this for us because we're going to show stateless DHCPv6 in action here, where we will get an EUI64 generated address. So let's go back to DSW1, right? And again, we're walking through the 3 different ways we can pick up an IPv6 address with respect to automatically picking that address up. So let's create another pool. So IPv6 DHCP pool, and that's a little long there. And we're going to say version 6 VLAN 30. Now, just like we did before, remember the difference between stateful DHCPv6, which we just did on PC2 VLAN 20, and stateless DHCPv6, which we're doing right now, PC3 VLAN 30, is that single command that we configured on DSW1. And if I were to say do show run interface VLAN 20, and actually it was, did I do that? I'm sorry, look at the pool. I was looking in the wrong place. Do show run and then include DHCP. And hold on one second here. I am at a loss, and maybe I'm just looking right past it. So the address prefix command that we applied to VLAN 20 in the pool that we created, we put the address prefix in there. Oh, let's do a do show run. I have a feeling that it's in here. I just didn't. Yeah. So address prefix. I was looking. This is what I was looking for. I apologize. So I didn't do section. I typed include, didn't I? Yeah, I said include. So what I should have said was, totally looked right past that. I should have said section DHCP because I was looking for the address prefix command. So here for VLAN 20. So that single command right there is the difference when we're configuring these DHCPv6 pools. That is the difference between stateful, which means we have that address prefix command in here. That means it's a stateful DHCPv6 pool, and we're doing stateful DHCPv6, or we don't have it, like VLAN 30. You can see here we've got the IPv6 DHCP pool for v6 VLAN 30. If we don't put the address prefix in there, if I just put in additional information like DNS server 2001:db8: Charlie1::53. We'll put a domain name in here, cisco.com. Let's put in an SNTP address of 2001:db8: Charlie1::123. Right? So with stateless DHCPv6, I want SLAAC to do the address part, right? Because we don't have, you notice, we don't have the prefix command in here. So let me let me repeat this one more time, because this is the most important difference between stateless and stateful. So here is my, come down, oops, sorry, I actually include that right there. So this is stateful. And the reason that this is stateful DHCPv6 is because of that single command right there, the address prefix command. That makes it stateful DHCPv6. And I'm going to rerun the show run section DHCP here in a second. We did not do that for this other pool that we just created right here. This is stateless because, again, I'm not controlling the allocation or I shouldn't say controlling the allocation. I'm not controlling the prefix that is being used as we do here in the stateful. So down here, I'm not managing that prefix. Up here, we are managing that prefix. And that is the difference between stateful DHCPv6 and stateless DHCPv6. Now, remember we talked about SLAAC right off the bat. SLAAC, Stateless Address Auto Configuration. And with SLAAC, we're basically taking a look at the prefix that we see in the router advertisement messages, and we're using that to automagically configure our EUI64 IPv6 address. Now, with stateless DHCPv6, you'll notice we didn't put an address prefix in here, because what we want to have happen is we say, you know what, we're fine. Go ahead and use SLAAC to get the IPv6 address. However, I also want to make sure that these other little tidbits of information, DNS server, domain name, SNTP address, that when the client gets his address through SLAAC, he also receives something that tells him, hey, there's other information I need you to get, or that I would like to provide to you. And that's where we're going to talk about the other config flag. And that's exactly what that O bit is all about. The other config flag says, I have other information that you need to pick up from me. And so let's go ahead and finish our config out here. If I were to say, do show run section DHCP, you can see that here is the stateful DHCP configuration and pool, and here is the stateless DHCPv6 configuration and pool. And again, remember that the only difference, or at least in this use case, the differentiator is stateful is going to have an address prefix command that is going to dictate the prefix, the global unicast prefix that we will use when configuring the address. So we've got the stateless pool ready to go for VLAN 30, and let's go ahead now and jump into interface VLAN 30. We're going to say IPv6 DHCP server. Now remember, I still need to say, hey, this is the pool you should be using. So v6 pool, and I actually think I just said v6 VLAN 30. Yeah, v6 VLAN 30. And here is the very critical piece of information. To make this stateless DHCPv6 work, and to make sure that it receives the additional information, I need to say IPv6 neighbor discovery, or ND, other config flag. So let's take a look what happens when I don't put that onto PC3. So if I come over here to PC3 right now, and I were to say show IPv6 DHCP interface Ethernet 00, you can see we don't have anything, right? Nothing is configured yet. What if I said show IPv6 interface brief? So what do I have? I've got an EUI64 generated IPv6 global unicast address. But that happened auto-magically for me because of SLAAC, right? Stateless address auto configuration. It'll work on its own, and it'll work whether I've got stateless DHCPv6 configured or not. And so that's how I've got the address. But when I run this show IPv6 DHCP interface command, I should be seeing, just like PC2 here, I should be getting the DNS server, the domain name, and that SNTP DNS server information. But I'm not. And this is where the other config flag comes into play. And you set it on the interface on which you want to communicate. So we're just flipping a bit, right? We're signaling, we're flagging anybody coming to us, asking for a or looking for an IPv6 address. We're going to tell them, hey, yeah, we're the DHCP server, and we have other configuration information we would like to give to you if you're interested in getting that information. And that's where we need to say IPv6, ND stands, and if I do a question mark here, ND stands for neighbor discovery, right? So IPv6 neighbor discovery, other config flag. So when I say that, DHCPv6 clients, stateless DHCPv6 clients, are going to receive a flag in the DHCPv6 messages telling them, hey, that guy that that you saw the router advertisement from, well, he also has some additional other information he would like to give to you. And let's see what that looks like now when I say show IPv6 DHCP interface Ethernet 00, and take a look at what happens. So that is stateless DHCPv6. Stateless because I'm not managing the global unicast prefix that's going to be ultimately configured on the client. I'm saying it's going to be stateless. So use SLAAC to get your address, but hey, we're going to do DHCPv6, and I'll put in quote, double quote, doing the quotes here, DHCPv6 Lite, where I'm not going to dictate the address prefix, but what I am going to let you know is, hey, I've got other DHCPv6 information I want to pass on to you if you're interested in getting that information. And all you need to do is with that DHCPv6 IPv6 DHCP server command is signal the other config flag. So if we were to come back to that video I talked about earlier, and we were to look here, here is the O bit, right? Well, when the O bit is set and these other bits are off, you can see we're doing stateless DHCPv6, right? And this is how that happens. Okay, this is how that works. And we have I think we had the on the client side we had the auto config flag set. I would have to double check that. Let's see if we had the auto config flag set on the interface here. Show run interface Ethernet 00. And yeah, and there's that IPv6 address auto config flag, right? So that is the significant difference between the two, stateful DHCPv6 and stateless DHCPv6. So let's take a look now on DSW1. If I were to say show IPv6 DHCP pool. So let's take a look at the two pools that we have here. And again, this is another, it'll demonstrate the striking difference. So this is DHCPv6 pool for VLAN 20. And this is our stateful, right? We're managing, right? We are managing and maintaining information here. So you can see the prefix that we've used to allocate. There's the valid time, the preferred time, and one in use. You can see down here on the stateless, which was VLAN 30. When we do the stateless DHCPv6, do I have a prefix indicated here? I don't. There's no valid preferred time. It doesn't track how many are in use or how many are not. Here, look at, we said active clients, it showed 1. And here we see active clients 0. Because again, we are not keeping track, right? We're not managing the state of the VLAN 30 addresses. However, we do want to give out other information to any clients. And again, the reason that it shows active clients 0 is because that only tracks leased out addresses. And so here we know that we have one leased address, right? And that's why that active client count shows as 1. So in fact, remember we did the show IPv6 DHCP binding? We can do the same thing, or I mean the show IP DHCP binding. We can do the same thing here. Show IPv6 DHCP binding, and there we go. And that is the bound address from the VLAN 20 where we are doing stateful, right? Stateful DHCPv6, and it shows that's the address that was given out, that ended in F4 echo. We've got our preferred lifetime, the valid lifetime. You can see the expiration date here, right? And here is the DHCP unique ID that is used to track this. And here is the client link local address for the client who is using this as their global unicast address. All right, well, this is definitely a nice segue into DHCPv6. Again, I definitely want to highly recommend you take a look to get a full understanding of the managed config flag, the other config flag, and the autonomous config flag. The M bit, the O bit, and the A bit would be to check out this video here that goes into a super deep dive on those topics. All right, well, this wraps up Discovery Activity number 5, where we talked about SLAAC, we talked about stateless DHCPv6, and we've talked about stateful DHCPv6. Remember, the difference between stateful DHCPv6 and stateless DHCPv6 is going to be the specification in the IPv6 DHCP pool of an address prefix. You put that address prefix in there, now we're talking stateful DHCPv6. All right, guys, well, thanks for watching, and I will see you all tomorrow evening.